So, in our class today, we are going to discuss about electric charges and electric fields. But in this class, I'm basically going to focus much on electric charges. So, in our class today, we understand where electric charges come from, how do electric charges behave, and what causes electric charge. So most of you have tried to rub a ruler against your ear or a balloon against your ear. So when you are rubbing a balloon against your ear, you notice that as you are removing the balloon, the air will remain standing, or as you finish rubbing your ruler against your ear, if you try to stick a paper on it, it will stick for some minutes, then drop. So that phenomenon where your air will remain standing after you rubbing it against the balloon, or when you rub your ruler against the balloon, then it sticks. That's what we call static electricity. So static electricity basically means the transfer of electric charge. So as you are rubbing the balloon against your ear or the ruler, you are transferring basically electrons from your ear to the balloon, or an electric charge. So basically an electric charge can either be positive or negative, depending. It can either be positive or negative, depending on the type of material you are using. So for example, as you are rubbing your air against your balloon, the air becomes what? The air becomes positively charged, whilst the balloon remains negatively charged. So these two charges, a positive charge and a negative charge, as we know it, like charges repel and unlike charges attract. So in our case, if we have a balloon which is positively charged and you have air which is negatively charged, so these two, they will do what? They will attract each other. Attract. Then, if you bring two balloons and try to rub them against your air, you also create static electricity by transferring the electrons from your air to the balloon. Then when both balloons become negatively charged, then you try to bring the balloons closer. You have a negative charge and a negative charge, which will cause repulsion. So the unlike charges do what? Attract, whilst like charges repel. So that's the first principle we talk about under electric charges. So basically, an electric charge which is positive is known as a proton. Then an electric charge which is negative is known as an electron. Yeah. So electrons are the ones which are transferable. So as each electron is being transferred, it carries with it an electric charge, which is 1.6 times 10 to the power negative 19 coulomb. So this is an electric charge an electron carries as it's being transferred. So the electric charge is represented by the letter E. So this this electric charge, which is represented by letter E, can either be positive or negative. If you are dealing with a proton, it's positive. Then if you are dealing with a negative, it's what? Negative. If you are dealing with an electron, you see negative. If you are dealing with a proton, you see positive. Yeah. So next thing we are going to talk about briefly about what? Conductors. So what are conductors? So conductors basically are materials which easily transfer electrons. E.g., we can have copper, these metal things, they are good conductors. They transfer electrons very well. Then we have also what we call insulators. So insulators, these are materials which do not easily or do not transfer electrons. Insulators. So insulators do not easily transfer electrons. Yeah. So we have conductors, they allow the transfer of electron easily. An example we have is copper, metal, zinc, anything that transfers electrons. Not that in our previous or in our junior year, we used to say transfer electricity, good conductors transfer electricity, but in here we understand that it's not electricity which is being transferred, but electrons are the one which are being transferred. Yeah. So yeah. So basically, before we move to the next one, I want to do so. Let's recap on what we have covered so far. We have covered that one, electric charges come about due to static electricity. Then we said that we have two types of charges, positive and negative charge. Then if we have a positive and negative charge, they will attract. If we have a negative charge and a negative charge, they will do what? Repel. Then we have an electric charge which is 1.6 times 10 to the power negative 19 coulombs. Then we have also discussed about conductors. As well as the insulators. Yeah. So next now we are going to talk about what causes the two charges to repel or to attract each other, because they can't attract each other unless there's something that brings them together or makes them to repel each other. So what makes the charges to repel or attract each other is what we call Coulomb's law. is described in Coulomb's law. So the force, of course, is the force. So the force which makes two charges, positive and negative, to repel is known as an electric force. So an electric force is what makes charges to attract. This force is described in Coulomb's law, which states that the electric force is the magnitude of Coulomb's constant multiplied by the modulus of charge 1, modulus of charge 2, divided by the radius squared, or the distance separating the two charges. So this formula is quite similar to Newton's law of universal gravitation, which says that the gravitational force is equals to the gravitational field multiplied by mass 2. Then you have the distance separating the two objects. Yeah. So as you look at these two formulas, you can find that we have two similarities here. One is that the force of gravity is inversely proportional to the distance. Also, the electric field is inversely proportional to what? The distance. So meaning, as the distance between the charges increases, the electric force will reduce. Similarly, if the distance is reduced, the electric force will do what? Will increase. Similarly to the gravitational field, if you increase the distance between the object, the gravitational field will decrease. If you increase the gravitational field, if you reduce the distance, the gravitational force will increase. Yeah. Then the gravitational force increases with the increase in mass of an object. So if the mass of an object increases, the gravitational field will also will increase. Similarly, if you increase the charges, the electric force will increase. So this is for the electric force. Then this is for gravitational. You have seen this formula you saw this formula last semester. And they will talk about this when you are covering the same topic. So yeah, then one difference which we can talk about is the gravitational force. You have to know that it's always attractive because it's always pulling the object towards itself. So the gravitational field is always what? Always attractive. Then the electric force can be repulsive or attractive depending on the charges, producing them. So it can either be attractive or repulsive, but the gravitational force is always attractive. Yeah. So now we move on to the values which you need to know when you are dealing with the electric charges. So the formula you need to know are: one, we have the Coulomb's constant, which is 8.99 times 10 to the power 9 newtons meters squared per coulomb squared. Per coulomb squared. Then we have also the mass of an electron, which is 9.11 times 10 to the power negative 31 kg. Then you have also the mass of the proton, which is 1.67 times 10 to the power negative 27 kg. Then last but not least, we have the electron, which is 1.6 times 10 to the power negative 19 coulombs. So these formulas, you have to know them, but most the mass, they don't give these three, because they know that they are simple, and you also get marks when a question they have asked you to calculate for the electric force. Then, for example, they haven't given you let's say they have given you a question where you are required to calculate the electric force. Maybe I haven't given the electric charge, but you are told that, okay, this is an electron or a proton. So you will know that, okay, a proton or an electron carries which charge? 1.6. So if you put 1.6, they'll give you 1 mark if they didn't give you what? The electric charge. Yeah. So basically you have to know them. So next, this is a diagram now representing the principles of charges. So we have on our left hand side, we have like charges. Then on our right side, we have unlike charges. So as we can see here, like charges, they are repelling each other. So here, now, let's say this is a question for physics. So basically most of your questions, they'll come like this, which will require you, one, to calculate the distance in case they haven't given you. You can also calculate the charge. You can also calculate what? The electric force. So here you have to know how to calculate these three things. Then if you have this like force 1 and 2, it means this force which is pointing this direction is the force charge 1 is exerting on what? Charge 2. That's why they put 1, 2. The force charge 1 exerts on charge 2. So this is the force which charge 1 exerts on charge 2. Then if you have the opposite to 1, meaning the force charge 2 exerts on what? Charge 1. So you have to understand this, because basically as you are writing, also you have to represent them. Okay, this charge is a charge 1, or this force is the force charge 1 is exerting on charge 2. This is the force charge 2 exerts on charge 1. And another important thing you have to know is that the electric force is always directed in the line connecting the two charges. So in our case, the line in connecting the two charges is in this direction because the charges are diagonal. But if we had the charges horizontally, so the force could have pointed like this. If we had them vertically, the force could have pointed them like this. Yeah. Then if you have more than one charges, as we will see in our next lectures, you have to use vector analysis to solve for the what? For the resultant electric force. Yeah. So one more thing you have to understand here is, so this force, these two forces, they are always equal but in opposite direction. It doesn't matter the size of the charge. The forces, they will always be equal. What I mean is, the force this charge is exerting on this will be the same as, so this force will be the same as this force. The only difference will be the signs, because this force, one force will be in the negative direction, then the other force will be in the positive direction. This law is the one, electric charges uses also Newton's third law of motion, which states that for every action there is an opposite equal reaction. Yeah. So the forces will be equal but in different direction. Doesn't matter the size of the charges. So I have a quick quiz. You can pause the video for those that are watching the recorded one. Then you solve. Then you play. Yeah. For those that are present, you can attempt it. Okay. So the quick quiz is saying, object A has a charge of positive 2 microcoulomb and object B has a charge of positive 6 microcoulomb. Which statement is true? A, the force exerted by B is 3 times the force exerted by B on A. The force exerted by A on B is the same as the force exerted by B on A, but in the opposite direction. The C part is the same, but the C part is same with A, but in the opposite. Yeah. So if we remember Newton's third law of motion says that the force which is applied, which A produces on charge B, should be equal to the force charge B exerts on what? A, but in the opposite direction. That's why we introduce the negative sign. So here the answer was B. So it doesn't matter the size of the charges. Yeah, the force will always be the same. The only difference that will be there is what? The sign. So we have an example. The electron and the proton of hydrogen. The electron and proton of hydrogen are separated on average distance by a distance of about 5.3 times 10 to the power negative 3. Find the magnitude force and the gravitational force that each particle exerts on the other, and the ratio of the electric force to the gravitational force. Then you compute for the acceleration caused by the electric force of the proton on the electron. Then you have to repeat for the gravitational acceleration. So this question is simple. The challenge is on maybe finding the ratio, but for part A, when you are calculating for the electric field, you can use this formula. Force is equals to Coulomb's constant, magnitude of charge 1, magnitude of charge 2 divided by the distance squared. So this formula will apply. The reason why I'm putting modulus is the sign won't affect. So if it's negative, you change it to positive. I was putting it in this modulus. Yeah. So when you put in, of course, for the charge, I gave you the values, which is 1.6 times 10 to the power negative 19 coulombs. Then the distance we have is here. Then the coulombs constant is 8.99 times 10 to the power 9 newtons. So if you plug in everything here, I'm not going to solve this question because my time was almost finished. Yeah, but I'll try my best to show you how to solve it. Yeah. So when you do like this, you basically solve for the electric force. Then for the gravitational field, so for the gravitational field, the formula you are going to use is gravitational field is equals to G, which is M1 M2 divided by R squared. So M1 I also gave you, M2 I also gave you, but at the end I'll give you all the values so that you go through this question, you try to solve. Then after solving, you can post the answers. Yeah. Or I'll put all the answers for you. Yeah. So for part B, you are going to use this formula where G is 6.67 times 10 to the power negative 11. Yeah. So this is the value for G. Then the R will remain the same in both questions. So for the ratio, you use, since they are saying the ratio of electric force to gravitational field, so which means the electric force should be on top to gravitational force. Then those values you find for the electric force and the gravitational force, you put them, then you solve. Then the answer will be about 2.3 times 10 to the power 39, which shows that the electric force is greater than the gravitational force. That explains why magnets stick and the gravitational field cannot pull them away. Yeah. Then for the acceleration, so the acceleration, simply use the formula force is equals to mass times acceleration. So here you are saying that they want us to calculate the force for a proton on the compute the acceleration caused by an electric force of the proton on the electron. So they want to to calculate the acceleration of what? Proton. So you take the mass of a proton and the force will keep on changing. So the force for the electric force, we solved it in part A. and part B we solved for the gravitational force. So then you can put here for electric force, mass for proton, also for gravitational force, mass for proton, and what? Acceleration. Then you can make A the subject of the formula, which will give us force of an electron over mass of proton, and force of gravity over mass of proton should be equal to the acceleration of proton. So these two formulas will help you calculate for the last part. Then for the values which you use, so the values that we use are mass of a proton, mass of the electron is 9.11 times 10 to the power 31 negative 31 kg. Then mass of the proton is equals to 1.6 times 10 to the power negative 27 kg. Then electron is 1.6 times 10 to the power negative 19 coulomb. Yeah. So basically, this was our class for today. It was just an introductory class. So, yeah. So next time, I'm going to continue. I'll continue on electric field going forward. But before that, you need to try this question and solve. Then we'll move on from there.